Good day, great friends. Welcome to the video. Today we are focusing on chemical bonding. Uh, so without any further waste of time, let's get right into this. So today we're just going to be focusing on what is called the atomic mass. So we're just going to be looking at how we calculate the atomic mass. Sometimes it's even called the molar mass. We're just going to be looking at calculating the molar mass of different compounds and just seeing how that is done. So before we can be able to do that, we need to be able to use our periodic table. So from our periodic table, we're just going to be utilizing what is called the atomic mass. So those are the values that are at the bottom of your atomic symbol, or the symbol of your element there. So those are the values that we're going to be focusing on, and I'll be referring to them as your atomic masses in the context of this video. So these are the different compounds that we're going to be calculating the molar masses for, and then we're just going to be looking at them individually. Now, firstly, we look at carbon dioxide. So it's C and O2. So if you can check, there's carbon and there's also oxygen. Now, from your periodic table, the molar mass of, or the atomic mass of carbon is 12, and then the atomic mass of oxygen is 16. But when we calculate the molar mass, or the atomic mass of the whole compound, which is CO2, we know that there's one carbon, so there will just be 112, and then we say plus, and then 16, and then how many oxygens are there? There's two oxygens, so we multiply the 16 by 2, and then we get 12 plus 32, which gives us 44 atomic mass units. Sometimes it's called AMU or AMU, and sometimes they use U. This just represent atomic mass units. Do the same thing even when we have a compound such as ammonia. So ammonia is N plus H3. So there's N, one N or one nitrogen plus three hydrogens. The molar mass of nitrogen is 14. The molar mass of hydrogen is only 1. So there we write down the 14, which is only one nitrogen, plus 1 times 3, which is the molar mass of hydrogen, times the 3 hydrogens that we have there. So it's 14 plus 3, which gives us 17 atomic mass units. Even for a complicated compound like sulfuric acid or H2SO4, we still do the same thing. There's hydrogen, there's sulfur, there's also oxygen. So the molar mass of hydrogen from your periodic table is 1. The molar mass of sulfur from your periodic table is 32. And the molar mass of oxygen from your periodic table is 16. So we say 2, I mean 1, and then we multiply it by 2 because there's two hydrogens in sulfur, so there's H2 plus 32, which is only the molar mass of sulfur, which is 1 sulfur in H2SO4, and then plus O times 4. So there will be 16 oxygens. I mean, there will be 4 oxygens times 16. So it will be 4 times 16 because we have 4 oxygens in sulfuric acid. And then we'll have 2 plus 3 plus 32, which gives us 98 atomic mass units.